Hi guys,
we are Group 9.
My name is Gong Hong.
My name is Eng Terry.
My name is Chan Zhao Hua.
My name is Roshan.
And my name is Sherilyn Wujin.
Today, our group will discuss sustainable waste management in the glove manufacturing industry. The glove manufacturing industry plays an important role in healthcare, food processing, laboratories, and industrial safety. Global demand for disposable gloves has increased significantly, especially following the COVID-19 pandemic. The industry is a major contributor to economic growth and employment in many countries. However, the rapid growth has created serious environmental challenges such as high water, energy, and chemical consumption. Significant quantities of wastewater, solid waste, and air emissions are generated throughout the manufacturing. If these wastes are not properly managed, they can cause water pollution, air pollution, greenhouse gas emissions, and excessive use of natural resources. These issues threaten ecosystems, public health, and contribute to climate change. So, according to the principles of sustainable development, industry should meet present needs without compromising the ability of future generations to meet their own needs. Sustainable manufacturing aims to achieve a balance between these three key pillars: economic growth, environmental protection, and social responsibility. Therefore, glove manufacturers are encouraged to adopt cleaner production methods, improve resource efficiency, reduce waste generation, and recycle or reuse resources whenever possible. Our topic is closely related to the United Nations Sustainable Development Goals, particularly SDG 6, clean water and sanitation by ensuring industrial wastewater is properly treated before discharge. SDG 12, responsible consumption and production by reducing waste and improving resource efficiency. Lastly, SDG 13, climate action by minimizing greenhouse gases emissions and promoting sustainable industrial practices. In this presentation, we will explain the glove manufacturing process, identify the main waste sources and waste types, discuss the environmental impacts and waste management challenges, and review the relevant environmental regulations. Finally, we will present our proposed wastewater treatment process design, which aims to reduce pollution, comply with environmental regulations, and support sustainable industrial development. With that, I would like to hand over the presentation.
Thank you, Isaac. Before discussing waste management, it is important to understand how gloves are manufactured. The main raw material used include natural latex or nitrile rubber, calcium nitrate, coagulant, sulfur, vulcanizing agent, chemical, accelerant, stabilizer, water, and various cleaning chemicals. Each material serves a specific purpose in producing gloves with good elasticity, strength, and durability. Let's go through the manufacturing process step by step. Okay, first step is compound preparation. Natural latex or nitrile rubber is mixed with additives such as sulfur, stabilizer, antioxidant, pigment, and accelerator to produce a uniform rubber compound with suitable physical properties. Next, the second step is former cleaning and coagulant dipping. Ceramic hand-shaped mold known as former are thoroughly cleaned to remove contaminants. They are then dipped into a calcium nitrate coagulant solution, which help the rubber adhere evenly to the former during the next stage. Third step is latex dipping. The coated formers are immersed into the latex or nitrile compound, forming a thin layer that will become the glove. After dipping, the glove undergoes stitching. During this process, warm water is used to remove excess protein, chemical, and residual coagulant from the glove surface. This improves product quality and reduces the risk of allergic reaction. Next is vulcanizing. The gloves are heated at high temperature, allowing sulfur to cross-link the rubber molecules. This greatly improves the glove's elasticity, strength, and durability. After vulcanization, the gloves are stripped from the ceramic formers, inspected for defect, tested for quality, and finally packed for distribution. Although this manufacturing process is highly efficient, it also generates significant waste. Large volume of wastewater are produced during washing, bleaching, and cleaning operations. Rubber scraps are rejected, and rejected gloves become solid waste. while boilers used for heating generate air emissions. These waste streams must be properly managed to minimize environmental impact. Now I'll pass to the next presenter.
Thank you, Zahong. So the glove manufacturing industry mainly produces three categories of waste, which is wastewater, solid waste, and air emissions. First is wastewater, which is the largest waste stream. Wastewater is generated mainly from formal washing, latex dipping, bleaching, equipment cleaning, and factory sanitation activities. It contains high concentration of organic matters, suspended solids, latex particles, ammonia, surfactants, and residual processing chemicals. If this wastewater is discharged directly into rivers without treatment, it increases biological oxygen demand, which is BOD, and chemical oxygen demand, COD. High BOD and COD reduce dissolved oxygen levels in rivers, making it difficult for fish and other aquatic organisms to survive. The next category is solid waste. Example includes rejected gloves, rubber scraps, sludge from wastewater treatment plants, used packaging materials, and damaged ceramic formers. If these wastes are disposed of improperly, they occupy a valuable landfill space of many contribute to microplastic pollution over time. And lastly, the third category is air emissions. This mainly came from boilers and heating systems used during vulcanizations. Typical pollutants include carbon dioxide, nitrogen oxides, sulfur dioxide, and particulate matters. These emissions contribute to global warming, climate change, and poor air quality. Overall, improper waste management affects water quality, air quality, biodiversity, and public health. Therefore, effective waste treatment is essential to minimize these environmental impacts. I'll now pass on to Roshan to discuss the challenges and regulations.
Thank you, Sharon. Although many treatment technologies are available today, glove manufacturers still face several challenges in managing industrial waste. Firstly, the first challenge is large volumes of wastewater. Since washing and leaching require huge amounts of water, factories generate thousands of cubic meters of wastewater every day. Treating such a large volume requires large treatment facilities and high operational costs. The second challenge is complex chemical composition. And the wastewater contains latex particles, suspended solids, ammonia, and surfactants, and other chemicals. Because of this complexity, multiple treatment processes are often needed to achieve acceptable discharge quality. The third challenge is increasingly strict environmental guidelines. Governments are enforcing tighter discharge standards, requiring industries to continuously improve their treatment technologies and environmental performance. The fourth challenge is cost. Building, operating, and maintaining wastewater treatment plants require significant investment, especially for advanced biological and tertiary treatment systems. Environmental regulations. In Malaysia, glove manufacturers must comply with several important environmental regulations. These include the Environmental Quality Act of 1974, the Environmental Quality Industrial Effluent Regulations 2009, the Environmental Quality Clean Air Regulations of 2014, and the Occupational Safety and Health Act 1994. Before wastewater can be discharged into rivers, it must satisfy regulatory limits of 4 pH, biological oxygen demand, chemical oxygen demand, total suspended solids, and ammonia concentration. Air emissions from boilers must also comply with national clean air standards. Besides complying with regulations, many glove manufacturers are adopting sustainable manufacturing particles. Examples include installing water recycling systems, using energy-efficient equipment, incorporating renewable energy sources such as solar power, and implementing waste minimization programs. Most manufacturers also follow the waste hierarchy. This means they first reduce waste generation, then reuse treated water, recycle rubber waste whenever possible. After that, recovery energy from suitable waste streams and only dispose of the remaining sludge at licensed disposal facilities. To improve environmental performance, our group proposes an enhanced wastewater treatment system. I will now hand it over to Terry.
Thank you, Roshan. Our proposed design focuses on wastewater treatment because wastewaters represent the most significant environmental concerns in glove manufacturing. Our design basis assumes a wastewater flow rate of 1,000 meter cubes per day. Based on our bacterial balance, nearly all of the processed water used during washing and bleaching eventually becomes wastewater. Therefore, the treatment plant was designed to handle the full daily wastewater flow while maintaining sufficient hydraulic retention time in each treatment unit. The wastewater contains high concentrations of chemical oxygen demand, suspended solids, latex particles, ammonia, and various chemical residue. Our treatment process consists of several stages. Firstly, the first stage is screening. Large debris and coarse solids are removed to protect downstream equipment. Second stage is the equalization tank. Here, the wastewater from different production processes is mixed together. This equalizes both the flow rate and pollutant concentration, ensuring more stable operation of the treatment plant. The third stage is coagulation and flocculation. Coagulants are added to destabilize fine suspended particles, while gentle mixing forms large flocks that can be removed more easily. The fourth stage is primary sedimentation. The heavy flocks settle at the bottom of the tanks, reducing suspended solids before biological treatment. Next is the aeration tank, which is the heart of the biological treatment process. Microorganisms consume dissolved organic pollutants, significantly reducing both BOD and COD. The treated water then enters the secondary clarifier, where biological sludge settles up from the treated water. Subsludges is recycled back to maintain microbial activity, while excess sludges is removed for further treatment. To further improve water quality, the treated water passes through sand filtration and activated carbon filtration. These units remove the remaining suspended particles, color, odor, and trace organic compounds. Finally, the treated water undergoes disinfection, typically using ultraviolet light or chlorination, before being safely discharged or reused within the factory. The treatment system is designed to comply with Malaysian environmental regulations by achieving acceptable limits for COD, BOD, suspended solids, ammonia, and pH. Here are some of the differences between existing and proposed processes. So currently, existing treatment includes primary treatment only, water discharge after treatment, higher freshwater consumption, higher pollutant discharge, and limited sustainability. And based on these problems, our proposed treatments are primary biological and tertiary treatment, and water to be reused, lower freshwater demand, better COD, BOD, and TSS removal, as well as supports circular water use. Compared with many conventional wastewater treatment systems that mainly rely on primary and biological treatment before discharge, our proposed design includes tertiary filtration and disinfection. This allows treated water to be reused for cleaning and non-potable applications, reducing freshwater consumption and improving overall sustainability. Now, passing over to Isaac.
Thank you, Terry. So, in conclusion, glove manufacturing is an important industry that contributes significantly to public health and economic development. However, the production process generates wastewater, solid waste, and air emissions that require proper management. Our proposed treatment system provides an effective and sustainable solution by reducing pollution, supporting water reuse, and ensuring compliance with environmental regulations. By implementing sustainable water management practices, the glove industry can continue to grow while protecting the environment for future generations. Thank you for your attention.
3, 2, 1.
Thank
Thank you.